Hi and welcome. Here's a quick update on the Schar's rotary table information that I posted with the Yuasa quick tool review. So I got a Yuasa rotary table because there was so much lash in this Schar's rotary table that it was vibrating back and forth and causing so much chatter that I broke a carbide end mill, 3/4 inch carbide end mill no less, while I was using it to cut. So I bought the Yuasa because I expected it not to have lash, and sure enough, it was pretty fantastic. Most features about this rotary table are exceptional, some even better than the Yuasa. So the squareness of this side, this face to this face over here, this one to this one, was superior on this rotary table when I measured it by a few tenths, which just blows me away. The Yuasa was flatter on the table side, which is pretty important, so that was a nice thing. But you know, this is a pretty darn well-made tool. Let me delve back into my experience with Schar's. So the only thing they've ever sent me to evaluate was their new caliper, their Aventur caliper line. By the way, I'm still using it every day. It's the one that lives on my lathe. It's my daily use. You can tell that it's seen a lot of abuse. Thing still works great. Still very, very happy with it. I reviewed that as one of my first videos when I started in machining. I was in a Simi Valley adult school around where I live and taking machining classes, and I just couldn't afford the big brands. Plus, I wasn't sure I was going to be that much into machining. So I was looking for an alternative supply of tools, and I ran across Schar's, and they were pretty fantastic. Now, in the early days, they did have some problems with the packaging of their shipping. Stuff would arrive with the boxes totally exploded. I never actually lost anything in shipping that I can remember, but the boxes came pretty worse for wear and the stuff inside tended to rattle around. Well, they've improved that significantly along with the rest of their tool selection. And over the years, they have been the hobbyist friend as well as, I'm assuming, professionals' friends as well. They've just steadily improved the quality of the tools that they sell under their name. So this is probably made by some Chinese or Taiwanese company. Schar's puts their moniker on it, but their requirements based on the cost they're willing to pay have been going steadily up over the years so that the quality of their tools just goes up. And a lot of their tools are pretty darn good, especially for the money. Well, I was very unhappy about the lash in the table on this guy, and I don't know if you can see that. I'm going to try and put attach this to my table after this introduction and measure the amount of lash that's currently in here. Well, anyways, someone from Schar's was watching my video. They said they watch all of them, which would be really complimentary, to be honest, but hard to imagine. But they said they were watching my video, and they realized that the lash is actually adjustable on this tool, and they sent me a PDF of the manual, which is right here. And I don't think I ever had a manual, but page 3, there's an adjustment in the secret hole in the side over here, right over here, that supposedly controls an eccentric cam, I think, that allows it to adjust how tightly the worm gear engages with the gear that rotates the table. So we're going to see if we can improve that. And if we can, then I'm just going to have another working rotary table. In some ways, that's superior to the Yuasa that cost 3 or 4 times as much. So supposedly inside here is this adjustment nuts, and you can adjust it and push the worm up against the gear on the table here. The manual, by the way, is very good. Every bit as good as the Yuasa manual I got. Except, let's see, do they have an exploded parts diagram? No, this just operates. So no, the Yuasa has an exploded parts diagram with parts you can order, but to be honest, this manual is pretty decent. So they gave instructions to adjust this. So first, let's clamp this guy down, measure how much rotation or how much lash it's got. I don't know if you can see that there, but it's a fair amount. Enough that it causes a carbide end mill to break by bouncing back and forth. And we'll see if we can adjust it tighter. And if we can, we'll have another good rotary table. And I need to take back my statements I made about it earlier on, which I'm happy to do. All right, so here's my setup. I've got a piece of 4140 pH plate here. Got a mag mount, got my indicator on here. This table's a little sensitive. This is a wooden workbench, not designed for precision work. I've got this clamped to the workbench. I'm just going to try and move this guy slightly. Let's see if I can zoom you in. Of course, there's always reflection going on here. All right, let's see what kind of motion we get. almost 10 thousandths, like 8.5 thousandths of lash right now. The adjustment location is in here. So in order to adjust this, you have to make sure that the worm is engaged fully, which it is now, just to double check. Then you take a 2.5 millimeter Allen wrench, loosen the ring and go counterclockwise, which you're not going to have a lot of range. So I'm guessing that, that is not a 2.5 millimeter. So this one's obviously old enough that, or they have a cover set screw in front of it, which they might have. I'll see here. So is there a set screw inside? So there was this slotted set screw or grub screw that's a pointed one. I'm kind of thinking no, but we'll see if I can reach in here and grab anything. Well, in that case, maybe this puts pressure against it and there is not a set screw underneath it. That is not a cover set screw. So maybe you simply tighten this guy down and it's what applies the pressure against the worm. That's a little tighter than it was when I found it. So let's take a look again. I suspect that my rotary table is older than the manual they sent me because that's probably for their current tool. And I've been buying stuff from Shars for 9 years or something like that. That's a little better. That is 7 thousandths. Let's see if tightening it, but that's clockwise. That really shouldn't be the right direction, but let's see if this one's different. So I'm tightening that set screw still more. Oh, look at that. Oh no. Nope. So they show a 2.5 millimeter hex wrench, turn counterclockwise to move the worm closer to the ring gear, create less backlash, or clockwise to create more backlash. Only small movements within the hex wrench turning too far will cause the set screw to fall inside the unit. As far as I can tell, there is no set screw. I removed this guy all the way, and maybe this one works. Maybe this one works by loosening this, tightening this in, and then retightening it again, re-engaging. I don't know, we'll try that next, see if that works, because clearly that manual does not apply to this guy. There's that set screw. And I guess this is the eccentric part here that you can rotate. And there's the worm. Actually, it looks pretty high quality. Looks like a lot of the grease has moved off the worm itself, but the shaft looks pretty high quality. That's a good chunk of grease right there. Probably would do better if it was on the threads. Thrust bearings right here. So something's got to apply pressure on the thrust bearings. That's very interesting. So it looked like this piece here rotates to set the centering of this guy. So this shaft is supported by this structure here, and as you can see, this is not centered. So as you rotate this, it controls how much this goes in, and the set screw is just a stopping point for it. I'm going to want to remove the rotary table itself. It's a really cool locking nut design. It's a split nut, and when you tighten the screw, it pulls the threads together and locks them in place. Really good design. And what we'll be holding in place now will be the locks here. There we go. And the gear is bolted to the rotary table with no bearings. Okay, I'm a little surprised about that. I expected to see ball bearings in here, but there aren't any. That's really surprising, to be honest with you. So it's two ground faces running on each other. Oh, and I guess that's supposed to be an oil groove. Although I don't see, Oh, there's the oil hole. They didn't quite get that lined up. So I guess when I put this back together, I thought grease would be a good solution, but I'm thinking it was designed for oil. I can set this guy up here and get this thing aligned again. I'm kind of curious as to what... Oh, there's nothing to hold the other end of this shaft. I thought that this would attach to something on the other end, but it does not. All right, so now this guy's here and we can go back. Oh, you can see, here you go. As you rotate, see I'm out of the way and back in the way. The set screw over there engages here and it sets the beginning and the end of this rotation. That's all it does. I did a quick CAD drawing and the eccentricity is off on it, but you'll get the idea. The set screw on one side, the left side, sets how far the worm can disengage with the ring gear. And that's not critical because it disengages with plenty of clearance. So no, you've got full range pretty much no matter what you do. On the other side, the conical point just barely engages the end, and that sets how far the worm goes into the ring gear as opposed to disengaging from the ring gear. So the range of motion is set by this slot and the two set screw positions as it rotates. Again, I have the eccentricity wrong, exactly opposite, but you still get the idea, I hope. Reassembly was pretty smooth. I cleaned all the grease out of the old one and put in new grease because while I was smoothing the grease around, I found huge chunks of metal stuck inside the unit, which is absolutely no good. So if you buy one of these, even a new one, I would probably recommend taking it apart. This piece here, I was wondering what it did, and it sort of sets the tension against the edge of the eccentric cam. So at first, I tightened it all the way and make it tight. When I found it, it was loose, and I thought, that's really weird. Well, it turns out it needs to be loose because if you tighten it all the way, which I did here, you can't rotate the shaft. It pushes on the eccentric cam too much. Next up, I prepped the eccentric cam rotation sleeve to be put on and find out that, yep, I can't turn the shaft at all. The eccentric cam is frozen. So I have to go and loosen those 4 screws so that it is movable, and now you can see that it is. I put the eccentric cam adjustment lever back on and tighten it, and then we're good to go. Then I have to put on the nylon bushing and the preload nut back on the shaft to preload the thrust bearings on the other side. Why they didn't use thrust bearings on both sides, I'll never know, because it would have been much better, because there's a lot of friction with the nylon washer, especially when you tighten it down. Also, the set screw on this guy pushes right into the threads, so you got to get it right. And the first time I don't get it tight enough, and it turns out that if you don't get the preload nut tight enough, the rotary table will move the entire worm back and forth and give you that play that we were looking at earlier. And that was one of the causes. The preload nut wasn't tight enough. So I actually have to do it twice and get it right the second time, because the first time it wasn't tight enough and there was way too much play where I discovered that problem. I discover here that the preload nut could go in far enough to reach a groove that they put for the set screw on it, only if the nylon bushing wasn't as thick, which is a problem because it needs to be that thick. So instead, the set screw pushes directly on the threads, damaging them. So you better get it right, as I mentioned earlier. Finally, it's time to put on the rotary handle, and here you can see I'm rotating it around to get the key lined up, except that the key slot is a normal design key slot, and they put this little nub of a key that only fits halfway. It only occupies half the slot, which is really weird. So when you push this on, it tends to rotate the key, which makes no sense. Why they didn't just put a full-size key, I don't know. But in any case, I finally get this thing together, and now we can give it a quick test and see if we can fix the play issue. Okay, so this set screw does the same job. It sets the range that this engages at. So you in order to change it, you have to loosen this guy, loosen this, disengage the worm, then adjust the set screw, re-engage the worm, and here you go. There's flex in the table. That's nothing at all. I don't know if you can see this. There you can see almost zero lash, but it's really stiff. So we'll disengage it, and we'll go clockwise just a tiny bit. They said do small amounts, re-engage. Boy, a little goes a long way, doesn't it? That's the preload. This slop here is that preload nut here. So we need to fix that as well. Okay. Now that I've adjusted the preload nut, now we're back to 1/2,000. It's stiff, but workable. I could work with it like this. So let's see what happens if you loosen, re-engage, tighten, and we're down to like 3,000 slash. That's very interesting, but a whole lot looser. So this set screw really does the work. So if I disengage this, and I said it was counterclock, we'll counterclock a little bit, re-engage, tighten. That's definitely noticeably tighter. That was a tiny rotation. 1/2,000. I think that's it. So the set screw on the side does actually do what the bushing did that you would tighten against in the manual. So this one's not designed the same way, but it sort of works the same way that set screw really does, with like 1/8 of a turn. Went from super tight to super loose, and these are all loose. The locks are loose, and we're down to about 1/1000th lash. So I'm happy with that. That's pretty darn good. It's reasonably tight, but workable. I could use this. Just got to use it two-handed, which is a lot like the Yuasa. So there you go. This is fixable. Thank you, Shars, for sort of pointing me in the right direction. This is an older model than the one you're currently selling, so it's designed a little bit differently, but the same sort of principle works. There's a set screw on the side over here. On the other one, you're reaching into a set screw on a rotating eccentric bushing, I think, on this that sets how far it can go. Different than this one, but this one works. It's very, very sensitive. You know, tiny little turn, like that much of a turn makes a huge difference between 3,000 slop and 1/2,000 slop, just so you know. One more thing, if you get a new one of these, I don't know how the new ones are manufactured, probably better than this older one, but I would still take it apart and look for metal chunks, because there were literally huge chunks of metal from the machining process still inside on the gears, which I removed, which might have caused it to hang up every once in a while. So definitely check that out if you're going to get one of these. A little bit of effort on your side can save you a boatload of money on the other side. And for those of us that don't have a ton of money to invest in a premium tooling, might be the solution for you. Anyways, thanks for watching. Hope you find it useful. Hope to see you next time.